Okay, so you should be here at 17.7, uses of equilibrium constant. And I'll be honest, I did not give you enough room on the original document to complete this problem. So I've added in a page that I'm going to kind of do some more work on. This is going to be a pretty long problem. This is actually pretty fun, in my opinion. But once the value of Kc has been obtained, the process can be turned around to calculate equilibrium concentrations from the equilibrium constant. So this isn't more of an application problem. Okay, so let's do one. This is how we can use the equilibrium constant in several types of calculations. Okay, so example 17.7. The equilibrium constant, Kc, is 3 for the following reaction at a given temperature. If 1 mole of SO2 and 1 mole of NO2 are put into an evacuated 2-liter container and allowed to reach equilibrium, what will the concentrations of each compound be at equilibrium? Okay, so this is a balanced reaction. I'm going to kind of zoom in here. Hopefully. Yeah, there you go. We are going to do a rice table, but I'm going to kind of move the rice table. Oh, sorry, that's the reaction. Okay. I'm going to do the I and the C a little bit lower, okay, to kind of give me some room when I zoom in. Now, because this is at a 2-liter volume, the molar concentrations for these aren't as easy. This is still pretty simple math. But SO2, if we do 1 mole divided by 2 liters, we're going to get 0.5 molar starting out. Same thing with NO2, 0.5 molar. And I'm going to kind of move that over. We have 0 of this starting out and 0 of this starting out. Okay. Now, at equilibrium, okay, we don't know what our concentration values are. That's what we're trying to find. But what we do know about the reaction is that since this is a 1:1:1 ratio, that SO2, we're going to get rid of some value X. Okay, same thing with NO2. Some value X is going to respond. Now, since this is a 1:1, this makes it real easy. We are also going to add a certain amount of SO3 and add a certain amount of SO3. We'll do a problem here in a minute where the coefficients are different there, because if there had been a 1 or a 2, that would affect our change. And then we're going to kind of add our equation down. So we know at equilibrium, SO2 is going to be 0.500 molar minus X. NO2 is going to be 0.500 minus X. SO3 is going to be X. NO is going to be X. Now what we're going to have to finally do, or try to do, is find the value of X. Okay? So let's write our equilibrium expression. Kc is equal to the concentration of SO3 times the concentration of NO over the concentration of SO2 times the concentration of NO2. And we've already determined from our given problem that that value is equal to 3. Now, let's substitute our equilibrium values here into our expression. And so if you do this, we have X times X over 0.5 minus X times 0.5 minus X. Now, the cool thing about this, and hopefully you've had this in your math, it might have been a while, is this right here is a perfect square. Okay, if you were to simplify this, you get X squared over 0.500 minus X squared. So what we can do to solve for X and make this really easy is we can take the square root of both sides. So I'm going to write that in kind of notes. Once again, I'm sorry that my handwriting on here is bad. So take the square root of both sides to simplify this. Okay, so I'm going to take the square root of 3, and I'm going to take the square root of this. Okay. Okay, and what that gives me is 1.73 is equal to x over 0.5 minus x. And then now all we have to do is use algebra and solve for x. So cross multiply. I'm going to show you each step. That way, in case it's been a while, we're going to distribute to both. What we should get is 0.865 minus 1.73x equals x. We're going to add this to the other side. And you don't have to show me each of these steps. I'm just showing you in case you maybe forgot or it's been a while since you've had some algebra, some very basic algebra. And what we get is 0.865 is equal to 2.73x. So if we solve for x, obviously you divide that off, you should get 0.3, my handwriting on this is awful, 317 molar. Now we're not done yet. Okay, all we've done is found x. Once you find x, to find your equilibrium concentrations, you need to go back and you need to plug it into each of these equilibrium expressions that you have. So what we get is SO2 is going to be equal to the concentration of NO2, okay, which is 0.184. Okay. Oh, my handwriting on here is so bad. And then SO3 equal to the concentration of NO, which that is X itself, so 0.317 molar. And those would be your final answers for this problem. And so you can see that this problem kind of was a pretty long one, okay, as we move on. So I'm going to stop the video and we're going to go